Welcome to our deep dive into interesting topics.
Great to be here.
Today, we're diving into, well, a really fascinating and pretty pressing issue, the environmental impact of artificial intelligence.
Yeah, it's something that doesn't always get the headline attention, does it?
Exactly. We'll be digging into the key insights from Jörg-Owe Schneppat's essay, AI Production of E-Waste and Co. 2.
Right. Schneppat's work really pushes us to look at the ecological side of this tech revolution.
So the big question we're tackling is, can we really embrace all the amazing things AI can do without, drowning ourselves in electronic waste and speeding up climate change? Let's find out.
That's definitely the core tension. Schneppat really forces us to confront the tangible footprint behind the algorithms.
Specifically, e-waste and carbon emissions.
Those are the big two, yeah. The physical waste and the energy cost.
Okay, so let's tackle this e-waste elephant in the room first. The essay mentions some pretty startling numbers.
Yeah, potentially up to 5 million metric tons of e-waste just from AI by 2030. It's a huge figure.
Wow. What's driving that? Is it just like more gadgets everywhere?
Well, it's largely the demand for these incredibly powerful data centers. Think massive buildings packed with specialized computers.
The engine rooms of AI, basically.
Exactly. And the issue, as Schneppat points out, is that this gear gets outdated fast. Technology leaps forward, so there's this constant cycle of replacing equipment.
Okay, so you've got this mountain of old tech piling up. What actually happens to it? The essay says only about 22% was properly recycled back in 2022?
Globally, yeah. It's not a great number.
So what's the holdup? Is the recycling tech not there? Or is it the logistics, the cost?
It's complicated. Schneppat's essay touches on how hard it actually is to get the valuable stuff back from modern electronics.
It's not just melting down metal.
Not really, no. You've got this complex mix of materials, some hazardous, some valuable like cobalt and gold, extracting them safely and efficiently. Well, it's technically tough and often expensive.
Right. So that complexity means a lot of valuable resources just get lost or mishandled.
Precisely. And that leads to pollution and waste.
It strikes me too, we focus on the waste part, the end of life, but the essay also highlights the environmental cost before it even becomes waste.
You mean the production side?
Yeah, making the hardware itself, the mining for all these materials.
Absolutely. Schneppat details that. Extracting raw materials has a big footprint. Habitat loss, water pollution, energy use.
So the problem starts way before you throw anything away.
The whole life cycle has an impact, yeah.
Okay, so there's the physical stuff, the e-waste, but then there's the energy needed to actually run all this AI. That's the other big piece, right?
Huge piece. The essay uses that comparison to the airline industry.
Yeah, data centers potentially emitting as much CO2 as the entire U.S. domestic commercial airline sector, around 131 million metric tons annually. That really makes you stop and think.
It does. It puts the scale of the energy demand into perspective.
What makes AI so power hungry? Is it just running the servers?
It's largely the training process for these big AI models, as Schneppat implies.
Yeah.
Teaching an AI, say, image recognition on millions of examples, that takes immense computation.
Right, crunching all that data.
Exactly. Immense processing power, which means immense energy consumption. And as AI gets more complex and widespread, that energy demand and the carbon emissions that come with it just grows.
Okay, so you've got this double whammy, piles of e-waste and massive energy use leading to CO2 emissions. Schneppat's essay isn't all doom and gloom, though, right? It talks about solutions.
It does. There's a clear call for improving how we handle e-waste. Better infrastructure, better processes.
Making recycling actually work better.
Yes, making it more efficient, safer, and recovering more of those valuable materials. And interestingly, AI itself might help.
How so?
Well, people are developing AI-powered systems for sorting electronics more intelligently, using robots for disassembly, kind of using the tech to solve its own problems.
That's actually a pretty neat idea, using AI to clean up after AI.
It's one promising avenue.
The essay also talks a lot about the circular economy. Can you unpack that a bit? What does it mean for tech?
Sure. So instead of the old take, make, dispose line.
The linear model.
Right. A circular economy tries to keep resources in use for as long as possible. So think reusing components, designing for easier repair, and then, at the end, effectively recycling materials back into new products.
Closing the loop.
Exactly. And Schneppat notes some companies are starting to look at this for data center gear, trying to make it more circular.
It sounds like it needs a push from different directions, though. Technology, business models. What about policy?
Oh, definitely. Schneppat suggests regulation is key. Things like extended producer responsibility.
Where the company that makes the product is responsible for its end of life?
Yeah, basically. Okay. It incentivizes them to design products that are easier to recycle or reuse and to set up take-back systems. Stronger regulations globally could make a big difference.
So really, this deep dive into Jörg-Owe essay, AI Production of E-Waste and Co. It really underscores that these incredible AI advances, they come with real environmental baggage we need to deal with.
Absolutely. Schnepfat's overview makes it clear. Balancing AI's potential with environmental sustainability isn't optional. It's probably one of the central challenges we face now.
We've looked at the big environmental hurdles with AI integration, the e-waste mountain, the carbon footprint from hardware and energy, all drawn from Schnepfat's work.
And his essay really highlights the urgency. We need better recycling. We need to adopt that circular economy model in tech. And we need innovation, maybe even using AI itself to lessen these impacts.
Just think about that potential e-waste figure again, up to 5 million tons a year.
Yeah.
And less than a quarter getting recycled properly right now. That's a huge gap.
It is, but it's also an opportunity, right, for new processes, new industries focused on sustainability.
And applying those circular economy ideas, reuse, repair, recycle, could fundamentally change how tech hardware is made and managed. Less mining, less pollution.
It's a different way of thinking about the whole system.
As Jörg-Owe lays out, bringing AI into our world means we absolutely have to think about these environmental costs. It's a critical reminder, really. Progress and responsibility have to connect.
Couldn't agree more.
So here's a final thought to leave you with, building on Schnepfat's points. As AI gets even smarter, could we actually develop AI tools specifically designed to predict, track, and maybe even actively manage the environmental footprint of AI itself? Could it create its own sustainability feedback loop? Something to ponder.